What is time? Have you ever found yourself gazing at the clock, pondering the nature of time? We all structure our lives around its relentless progression, from when our alarm goes off in the morning to when we finally go to bed at night. But take a moment to consider, what exactly is this intangible force that governs our daily routines and our very existence? If you hop online and look up what is time, you'll probably come across something like this. Time is the ongoing sequence of events that happen in an irreversible order from the past through the present and into the future. That makes sense. We're constantly moving forward, leaving yesterday in the past as we step into tomorrow. However, this widely accepted concept of time only works well with some. Many scientists and philosophers question this idea and even the existence of time itself, suggesting that it might be an illusion. Now, let's talk about measuring time. It's something we've all mastered. 60 seconds to a minute, 60 minutes to an hour, 24 hours to a day, and so on. Clocks and calendars practically run our lives. But here's a brain teaser for you. What are we measuring when measuring time? This question has puzzled the brightest minds for centuries. Time and change. Delving deeper into this topic, we can draw inspiration from the timeless wisdom of the ancient Greek philosopher Aristotle. He notably expressed the idea that neither does time exist without change. This thought-provoking statement encourages us to contemplate a world where change is absent. In such a static universe, even the movement of light would cease. The distinction between today, tomorrow, and yesterday would become indistinguishable in this context. Terms such as now, before, and after would lose their significance, leading to a re-evaluation of the very concept of time. This perspective, initially articulated by Aristotle, continues to captivate the minds of contemporary thinkers, prompting us to reflect on the intricate interplay between time and change. Presentism. Presentism, possibilism, and eternalism. Contemporary philosophers have put forward intriguing concepts concerning the nature of time, giving rise to three prominent theories: presentism, possibilism, and eternalism. Presentism posits that only the present moment is real, with the past having ceased to exist, and the future yet to materialize. Possibilism suggests that the past and the present exist while the future remains undecided. On the other hand, eternalism, also known as the block universe, proposes that the past, present and future all exist simultaneously, with each moment being equally real. These theories, intriguing as they are, lie in the abstract realm of philosophy and metaphysics. So, what does science have to say about time? SpaceTime. In physics, time is considered a dimension combined with the three dimensions of space to form the concept of spacetime. Most of us have a basic understanding of four-dimensional spacetime. For example, you might have an appointment at 20 Main Street on the 6th floor on June 10th at 2:30. By incorporating the dimension of time into the three dimensions of space, we establish a four-dimensional coordinate, or an event, in space and time. We instinctively grasp this concept as when and where. But what would happen if we could not agree on when is when? In the theory of general relativity, one of the fundamental concepts is that time is relative. This means that the passage of time is not fixed, but rather depends on the observer's frame of reference. Specifically, it is affected by factors such as the observer's motion and the gravitational field therein. Consequently, time can elapse at different rates for observers based on their relative motion and the strength of the gravitational field they experience. Consider a scenario involving a pair of identical twin sisters. If one of them were to embark on a space journey at a speed close to that of light, according to the theory of relativity, time would pass more slowly for her on the spacecraft than it would for her sister on Earth. As a result, when the space-traveling sister returns to Earth, she will be younger than her twin, who remained on Earth. This phenomenon is a consequence of time dilation, where the faster an object moves through space, the slower time passes for that object compared to an observer at rest. Additionally, massless particles, such as photons traveling at the speed of light, do not experience time. Gravity has a similar impact on time. The stronger the gravitational field, the slower time passes. Quantum mechanics and general relativity present different views on the nature of time. Quantum mechanics regards time as universal and absolute, while general relativity considers time as flexible and relative. In the realm of quantum mechanics, it is proposed that at the subatomic level, the fundamental laws of physics exhibit symmetry even when time's direction is reversed. Experiments confirm this for electromagnetism, gravity, and the strong nuclear force, with the weak nuclear force showing a slight deviation. Essentially, there is no preferred time direction at the subatomic level, and the laws of physics remain unchanged, whether time moves forward or backward. This concept challenges our everyday understanding of time and raises intriguing questions about the universe's nature at its most fundamental level. In theoretical physics, the clash between general relativity and quantum mechanics raises questions about the true nature of time and its singular direction. This captivating conflict delves into whether time is a distinct phenomenon or an emergent property of a deeper underlying reality, leading the likes of Albert Einstein to ponder whether time was real or merely an illusion. Have you ever found yourself staring at a tangle of electrical cords and cables, wondering how they became so knotted? It might seem like they just magically went from being neatly organized to a chaotic mess at your feet. But deep down, you know that there's no magic involved. You understand that the wires gradually became tangled over time due to subtle movements. You also realize that without making a conscious effort, the tangled mess won't just magically sort itself out. It will only continue to become more disorganized as time goes on. This is because the second law of thermodynamics, or entropy, states that everything in the universe eventually moves from order to disorder. Entropy is a unique concept in the physical sciences as it is associated with a specific time direction, often referred to as an arrow of time. According to the second law of thermodynamics, as time progresses, the entropy of an isolated system can only increase and not decrease. For many physicists, this is tangible evidence that time exists and has a single direction. Is time just a concept humans use to measure moments and events, or does it have a concrete existence, like the steady movement of a ticking clock, fundamentally shaping how we perceive the world? Perhaps the answer already exists in the future, tucked away in some corner of the block universe, waiting to unfold. Or maybe time is beyond our comprehension, and its nature will continue to elude us until the end of time. What then is time? If no one asks me, I know what it is. If I wish to explain it to him who asks, I do not know. St. Augustine.